Welcome Algebra 1 students. Thank you for watching. The final exam review packet problems worked out. Problems 22 to 31 are the ones I will be doing for you. So if we look at 22, it asks us to look at the graph. And we see a bunch of points. Then it asks which of the following points, if added to the graph above, will cause the relation not to be a function. Well, something is not a function if it fails the vertical line test. Okay, so let's consider that. Let's maybe plot our points A, B, C, D and see which one will make us fail that vertical line test. So failing the vertical line test means our function, say our function is in blue, if our function just hits once as it moves vertically, it passes. But if in red it hits twice or 3 times, then it would fail. All right, so the point 2, 3, 2, 3, that point would not affect it. It still passes a vertical line test. That is point A. Point B, 4, 2, 1, 2, 3, 4, 2. It still is okay. It passes the vertical line test still. 3, 2, 3, 3, negative 2, aha. Now this already has a point. This x value already has a y value associated with it. So this point C, sorry I didn't label my B, point C is going to make this relation not a function. Alright, so C would be my answer. I want to maybe check D and make sure that's not the answer and I missed it. So 0, negative 4. And it looks like there is no other point on that x value. So C would be the one that would create this relation to not be a function. All right. Number 23, which of the following statements is true about that statement? F of 5 is 12. And I encourage every time you see f of something, you put f of x. Maybe it's f of t, but put something above it so you can see, my x is 5. And if I input a 5, my output, my y, is 12. But in this case, it's f of x. So my x and my y. So the point 5, 12 is on the graph of the function. That is true. The 5 is my x, the y is my 12. The number 5 is an element of the range. And when we think range, in my class I said, X, we dance on the domain and we raise the roof for the range. It's just to help us remember the D and the D and the R and the R. So range, we're talking about up and down, and that is our Y values. So is 5 an element of the range? No, that's part of the domain. So we know that's not true. And 12 would be the value of the independent variable, and 5 would be the value of the dependent variable. And at the very beginning of this unit, I think we were talking about pool store stuff. We were saying the independent variable is the input and the dependent variable is the output. So like if we buy 5 shirts, 5 is the independent variable, the output is the cost. That would be the dependent variable. All right, so in this case, 5 is not dependent, 5 is the independent. If we bought 5 shirts, it would cost $12. So that would be also false. Correct answer would be A. All right, hopefully you already got that because you already worked them out. If you haven't worked them out yet, you might want to try that and then come back and watch this, or even hit pause and try it. All right, next one. What is the value of f of 5? What advice did I give you just a second ago? It's okay, nobody's watching. You can say it. What? F of 5. What should I put above it? Yes, f of x. Good. That helps me see x is 5. So everywhere I see a x in here, I'm going to put a 5. So this says 3 times 5 minus 2. 3 times 5, let me write this out better. F of 5, 3 times 5 minus 2. 3 times 5, 15, minus 2 would be 13. So f of 5 is 13. And I check my answers, and yep, it's there. It's very important that you do your work and then check your multiple choice answers. If you just maybe, well, you could work backwards, I guess. But I think showing your work is always a really good idea on final exams. All right, this one is asking us to sketch a graph on the axis below for a function f of x with the following characteristics. So, wow, there's a lot of characteristics. Let's start and see if we can get each one in there. The function has x-intercepts of -3 and 2. X-intercepts. Intercept means it crosses, so it crosses the x. Here's my x. It crosses the x at -3 and 2. -3 it crosses, and at +2 it crosses. So we need to go through those 2 points. The y-intercept, so it crosses the y at 3. Here's my y-axis, and it crosses at 1, 2, 3. So we're going to have to go through all 3 of those points. Then it gives me some information. F of -4 is -5. F of 4 is -3. So this is really giving us a point. When the input is -4, the output is -5. Sorry, let me write this clearer. -4, -5 is a point on my graph. So is 4, -3. So I need to go through those 2 points. -4, -5, and 4, -3. All right, doing good so far. The function has a maximum value at that point. Let's see, -1, 4 is the highest it will go. We'll never go above that. Okay. The function is increasing when the x values are between -4 and 1. So, from -4 to 1, oh wait, I'm sorry, from -4 to -1 to -1, we are increasing. So let's see if we can increase from -4 to -1. That's increasing that whole time. Okay? And it's decreasing from -1 to 4. So we're just looking at the x values. So on this axis, we have to be going down during those values. -1 to 4, between here and here, it's going to be decreasing. All right, with the sound effects. All right, so that would be our graph. Let's see if we fit all that. We have 2 more requirements. Let's check them. The domain of the function is between -4 and 4. Remember, dancing on the domain. You can dance on the x-axis because it's flat. So dance on the domain. Domain is -4 to 4. Let's see. Did we start at -4? Yep. Did we stop at +4? Yes, we did. So we're good on that one. All right. And what else? The function is continuous. So I actually connected my dots before I even knew. Maybe it was supposed to just be discrete and have dots. But luckily, it was supposed to be continuous, and I was supposed to connect. So with continuous, some of our students, were thinking that continuous meant it had arrows on the ends, but that is not the case. Continuous just means that it's connected and that the values in between 2 whole numbers are also solutions, right? So we can have halves. Like if we were counting people, we couldn't have a half a person. But if we were counting time, we could have a half a second or a half an hour. So we have to think about it carefully. All right. Aha, now those of you that are doing presentations, this might be a very important problem for you. So the graph below represents the temperature in degrees Fahrenheit inside of a freezer as a function of time. The variable t represents the time in hours since midnight. So this is very important. I've been using x and y, but now it's saying we're using t and f. So this is Fahrenheit and this is time. So we're going to be careful to put t and f in our problem. What is the domain of the function? We were just talking about dance on the domain. So domain is the values of the x. I'm doing air quotes, but you can't see it. So the x value is now t, right? So we are starting at 0 and we go all the way to 7. And it looks like that's where we are. And we have to ask, are we going to list out 0, 1, 2, or are we going to state all the values in between? So we have to ask ourselves, is it discrete or continuous? And in this case, because it's connected, it's continuous, we're going to have all the values, every single value, not just the whole numbers. So, in order to get the domain of the function, we want to say between 0 and 7, all the times in between that are less than or equal to 7, or greater than or equal to 0. So all times between 0 and 7 hours is what it says. Now another way, that's inequality notation, but you can do interval notation from, say, from 0 to 7. I feel like this is a little simpler. So just a quick review, this means included. This means not included. And not included would be something like if you had an open circle, and included would be means you have a closed circle. Just a quick review. Okay, so range is the raise the roof, right? Range is the y's. Oh, I should have put x over here. Domain is the x, range is the y. But right, that was actually t, and this is actually f. So let's go and look at the range. Range, let's see, the lowest it is, we always want to start low to high. So the lowest it is -3, and the highest it goes is +3. So from -3 to +3, all my Fahrenheit's in between, less than or equal to, Fahrenheit's greater than or equal to -3, or again, interval notation, it is equal on both ends. So you could do either one of those, you don't have to do both. All right? What is the meaning of the F-intercept? Let's see, it crosses the F right there. So what is the meaning of that? Well, right here, that is when time is 0. And it said also since midnight. So t is hours since midnight. So what that dot represents is at midnight what the temperature was. So the temperature at midnight. That is what it represents. We could say is -2 degrees Fahrenheit. Okay. Then we're asked, at what time, T, is the minimum temperature reached? So we want to find where is our minimum. Our minimum, the lowest it goes is here. At what time? Aha! At 6, after 6 hours. So 6 hours from midnight. What T? At T equals 6. That is where our midnight is. I'm sorry, that is where our minimum is. All right, on what interval of time is the temperature decreasing? Aha, now I always start on the left and read my graph left to right, just like we read words in English. So, on what interval of time is the temperature decreasing? Am I going down right now? No, I'm definitely going up. Okay, so I'm going up, 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 and then I stop, and then I'm going down. And then I go up again. So I need to figure out where did I start going down and where do I stop going down. So I'm going to drop some perpendiculars here. I think you'll learn about that in geometry. But if you drop a line, it helps you see, we started decreasing at 3 after 3 hours. And we're decreasing, 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 and then we stop decreasing, and we start increasing. So we already have that one highlighted. So between 3 and 6, that is the time when I'm decreasing. A lot of people want to say from this to that. So be careful. They're asking on what interval of time, so they're saying T, give me values of T when my temperature is decreasing. From 3 to 6 is when the temperature is decreasing. And we could say from 3 to 6, all the values in between. Now, the county is telling me that it should be included, but I kind of disagree because I feel like at that point, it's not decreasing, but after that point, it is decreasing. So I think either one of these would be acceptable. Included or not included. You could also say T, the values of T between 3 and 6, and like I said, if you want to argue that it's not actually decreasing at 3 and at 6, you would say not equal to. All right. Last thing, what does the statement f of 5 equals -2 represent in the context of the problem? And this one we have to make sure we're writing words and explaining in the story. That's what that's saying, in the story. So 5, that means after 5 hours, let's say 5 hours after midnight, so 5 hours after midnight, the temperature is -2 degrees Fahrenheit. Sorry, I should have used a different color. All right, great. So good luck presenting those. I'm sure you'll do great. Try to make it exciting so that everybody's paying attention. All right. Let's see. 27 has 6 problems, and it's asking, for each relation below, determine whether or not the relation represents a function and justify your answer. So we've got a couple of ways to justify whether something is a function or not. We can check the vertical line test and see, does it cross only once? And here it does. So we're going to say, yes, this is a function. It passes the vertical line test. And some people were tempted in my class to write the pencil test. And I'm going to ask that, that's a middle school thing, and now we're in high school, so we're going to call it the vertical line test, because that's more formal. Okay, now if I go and do the vertical line test here, I am going to fail because it fails vertical line test because it hits more than once. So we're going to say no, it is not a function. Let's see, what does it say? Determine whether or not the relation is a function, justify your answer. Let's actually state it. This is not a function because it fails the vertical line test. All right, then we've got some ordered pairs, and we need to check our inputs. And the inputs looks like 2, 2. Looks like we have 2 values, 2 inputs that are the same. So our input repeats and our output is different. So that makes it not a function. This is not a function. I'm going to write it so that the video is not so long. I'm going to pause and write it, and then we can read it. So we're going to state this is not a function because the input of 2 has 2 output values. So this fails. If we were to plot those points, it would fail the vertical line test. All right, over here we've got 4, 6, 11, 10. All the inputs are different, so yes, this is a function. All right, then we've got, let me pull this up so we can see it better. I can see it better. Here we have 4, 5, aha. Now 5 goes to 4 and 5 goes to 8. So again, this is not a function because the 5, and notice I'm justifying. When it asks me to justify, I need to explain why. I can't just say no, yes. That's not enough. In this situation, this problem might be worth 2 points. 1 point for whether it's a function or not, and another point for your justification. So this is not a function because the 5 has 2 output values. All right, let's switch colors. And the last one, 4, 8, 1, 2. Ah, now because this both goes to 9, do you feel like maybe that's not a function? Well, it actually is. As long as each of these has only one place to go, then we're good. Here we had 2 places to go, didn't work. So there's only one output for each input. So this is a function. Because each input has one and only one output. All right, let's see what else we got. Aha, okay. These are those really challenging problems that make you think and make you be really meticulous. So we have 2 functions, f and g, and I'm going to go ahead and color them. This is my f function, and this is my g function. Whoop, I got off there a little bit, sorry. All right, so we have to decide which is this one greater than that one? is this one less than that one, or is this one equal to that one? So we either need to put greater than, less than, or equal to inside here. So I need to identify f of 2. F of 2. And again, I was encouraging, and I will still encourage for you to write f of x above. So you're like, oh, yeah, x is 2. If x is 2, how high am I? Ah, I'm 3 high. So this one is equivalent to 3. If I was on my g function, I'm going to say, okay, g of -1, g of -1, I go up to g, and it's at 3. Ah, hey, looks like these two are equal. All right? Then we look, if you haven't tried this yet, maybe you want to pause it and try it, and then hit play and check your answers. So x-intercept of f. I'm going to go back to blue, f-intercept of x. I'm sorry, f of x, the x-intercept. So where does my blue function cross the x-axis? Looks like at -1. So on this side I have -1. The y-intercept of g, where does g cross the y? Right here at 1, 2, 3, 4. Aha, so -1 and 4, which one's greater? Definitely 4 is greater than -1. Here we have to find two values and then multiply. F of 1, f of x, f of x. If x is 1, and I'm on my blue function, x is 1, I'm up here at 2, and I'm going to multiply that times f of 3. 1, 2, 3, x is 3, go up to blue, 1, 2, 3, 4. It looks like we're up at 4. 2 times 4 is 8. Ooh, that's pretty big. Okay, and on this side I'm supposed to add g of -1 and g of 2. Again, g of x, g of x. If x is -1, x is -1, g is 3. And here, g of 2, if I go to 2, I'm at 3. 3 plus 3 is 6. Which is bigger? This one's bigger. All right, so that would be problem 28. I am going to have to stop the video now. I feel like it's going to be too long. Anyways, so it will be 2 separate videos, and we will do 29 to 31. This one's a good one. So we just did a quick review. Hopefully you can try the problem 29 before you watch the other video. Okay, thanks for watching.